this lesson, we are going to determine if a relation is a function. Our target after we are finished with the lesson is, I can determine if a relation is a function given a set of ordered pairs, a mapping diagram, and a graph. Before we get started, let's review some definitions. A relation is a set of input and output values usually represented in ordered pairs. The domain of a relation is all the x values or input values of a relation. The range is all the y values of an input values in a relation. And finally, a function is a relation in which each element of the domain is paired with exactly one element of the range. Another way of saying it is that there is one and only one output or y value with each input x value. Sometimes functions are compared to a machine, saying whatever x value you put in, you perform the function, you get out a y value. For it to be a function, when you put in the number 1 and you perform the function, you must always get out the same number. Let's say 2. That makes a relation a function. There's some notation that you need to recognize when working with functions. We have y equals f of x. So what that means is now, instead of saying y equals something, when we're in function notation, we're going to say f of x equals something. So y and f of x are interchangeable. Y is your output, f is the name of the function, and that can change. It doesn't have to be f, it can be h, it can be g, it can be any letter. And x is your input value. So what you need to remember is that y and f of x are interchangeable. They're equal to each other. Now here are some examples. Here is a relation. 2, -3, 3, 0, 5, 2, and 4, 3. So if you're looking at the function machine, if I put in the x value of 2, I get out the y value of 3. If I put in the x value of 3, I get out the y value of 0. If I put in 5, I get out 2. If I put in the x value of 4, I get out 3. The domain of this relation is all my x values, 2, 3, 5, and 4, coming from x. 2, 3, 5, 4, or looking at this column, 2, 3, 5, 4. The range are all the y values, 3, 0, 2, and 3. Here they are listed again. So here is my range. This relation is a function because these x values only have one y value to go with them. So none of the x values repeat. They all only have one y value. Now I know that 2 gives you a 3 and 4 gives you a 3. That is okay. The y values are allowed to repeat. You just can't have 2 giving you 3 and then possibly 2 giving you 0. Let's look at the second example. This one is not a function. Because if you look, you can see that when I put in the x value of 5, I get out 2. And if I put in the x value of 5, I also get out 3. And you're not allowed to do that with a function. 5 is only allowed to give us one y value. So you can see in the domain we have 4, 5, 5, 6, and 1. This is not a function. The x values repeat. 5 is paired with 2 numbers, and it's only allowed to be paired with one number. Here's one more relation displayed as a list of ordered pairs. We have the point 1, 3, 2, 3, and 3, 3. So the domain is 1, 2, and 3, and the range is just 3, 3, 3. This is a function because each x value is only paired to one y value. It is all the same y value, but that doesn't matter. The y values can repeat. The x's are just only allowed to go to one value. Alright, now let's look at some other ways relations can be displayed. They can be displayed as a mapping diagram or as a graph. First, we're going to look at mapping diagrams. This is an example of a mapping diagram. So here's the diagram. You have a circle that represents the input values, and you have a circle that represents the output values. So in the input, this is our domain. We have 0, 1, 2, and 3. You make the ordered pairs by following the line. So when I put in 0 to the function, I get out -2. So I have the ordered pairs 0, -2. But then I put in 0, and I also get out 1. So I have the point 0, 1. This right here makes this relation not a function because the x value 0 goes to two different y values. It repeats. It's not allowed to happen. So the rest of the relation's ordered pairs are 1, 2, 2, 1, and 3, 4. So you can see that domain has that repeated x value. 0 is used twice, and it gives out two different y values, making this not a function. So when you're looking at mapping diagrams, to determine if it's a function, you do not want two lines coming out of the same input or x value. All right, our next example. Does the mapping diagram represent a function? That's what we are asking. So when I look at this first example right here, I'm looking at the x column. I want to see, does each x value only have one line coming out of it? And you can see that the number 4 does not. The number 4 has more than one line coming out of it. 4 maps to 0, it maps to 2, and it maps to 4. And it's not allowed to do that. So your x values repeat, so this one is not a function. All right, let's look at the next example. Example number 2. One line, one line, one line, one line, one line. So this one is a function. And if we look at the third one line coming from 1, one line coming from 0, one line coming from 1, sorry, this was -1, one line coming from 2, and one line coming from 8. So this one is a function. All right, now let's look at relations as a graph. First, let me see if I can get rid of this stuff. Sorry, I'm new at using this hover cam, but I like it. All right, so here we go. These are examples of graphs. So here's the first one, and you can see it's just a set of ordered pairs, or points. And that's okay. A relation can be displayed as a set of ordered pairs or a set of points on a graph, or it can be displayed as a continuous curve. Now let's see how we can tell if a graph is a function. To determine if a graph of a relation is a function, it must pass the vertical line test. And the vertical line test is sometimes also referred to as the pencil test. Meaning that if I take a pencil, or a marker in this case, and I slide it across the graph, then it's only going to touch the graph at one point at a time. So when I look at these three examples here, this one is a line, a straight line. So you can see all the little vertical lines through it, that they only cross at one point. So this one is a function. Here's the graph of the second one. And you can check each line here. You can see at each vertical line that's placed over the graph that it only passes through the graph at one point. So this is also a function. Now the last one, our oval, if you take one of the vertical lines and you look at it, you see that, that line passes through the graph 2 times. So this is not a function. So you need your graphs to pass the vertical line test in order for them to be a function. So we got 4 examples here. The first one is a horizontal line. So you can see at each one of those vertical lines that represent our vertical line test that we only hit 1 point on the line. So yes, this is a function. Number 2 is a vertical line, and I know it's hard to see, but this is where it is. So trace that one or highlight that one on your handout. And if I would go and do the vertical line test, if I use my marker, you can see that at this point, I touch every point on that line. So this is not a function. Again, this one, if I spot check one of these vertical lines, I see that it crosses at 2 points. So this is not a function. And the last one, if I look and I spot check the vertical lines, I can see that I'm only touching the vertical lines or the graph. Each vertical line is only touching the graph at 1 point. So this one is a yes. It is a function. Alright, so what I have left for you are 3 more examples for the vertical line test without the vertical lines. So I'm going to use my pencil on the first one, and I'm going to slide through and see that this marker only passes the graph at 1 point each time. So this is a yes. Now my last 2 examples are sets of ordered pairs. So here are the points. And I see if I use the y-axis as a vertical line that it touches 2 points. So this is a no. It is not a function. So when I look at this one, I see only 1 point of this vertical line touches 2 points. 1, this one touches 2, and this one touches 2. So this is a no. Because if I pass my marker across, when I get to these 2 points, they both are touching my marker. When I get to these 2 points, they both are touching my marker. When I get to these 2 points, they both are touching my marker. So this is not a function. Alright, I hope you enjoyed your lesson on determining if a relation is a function. I'll see you in class tomorrow for some practice problems.